Here is the topic on Leibniz rule of differentiation of integrals. So it is not very hard topic, we can do it easily. So we could start from the basics, or let's get started. At first we are taking the differentiation with respect to x of a function, let's say capital F of x. It gives us a function of x, let's say it is small f of x. The above equation can be written in the form d of f of capital F of x equals to small f of x into dx. We are taking integrals in the both sides. Then it gives us, as we know that the integration of dx, it gives us x. So here it will be capital F of x equals to integration sign small f of x into dx. Here we will introduce the definite integral. As we know that in definite integral there are limits. In upper limit we are taking a, and in lower limit we are taking small b. Then the answer will be capital F of a minus capital F of b, because of by the definition of definite integral, upper limit minus lower limit. So these are the basics of differentiation and integrals. We will use it later. Now our problem is differentiation with respect to x of an integral. Here the lower limit is taken a constant a, and the upper limit is taken small x. The function is f of t dt. What will be the answer? Here we will do first the integral, then we will differentiate it with respect to x. So the answer will be d by dx. We are using the definition of definite integral, so the answer will be capital F of x minus f of a in the bracket. Okay, so as we know that capital F of a, it is just a constant, it is not the function of x. So the differentiation with respect to x of capital F of a, it is 0. So the remaining term is d by dx of capital F of x. So it gives us f of x because of it is the definition of differentiation as we have taken earlier. So our next problem, that is differentiation with respect to x, where the upper limit is chosen a constant a and the lower limit is x. Then what will be the answer of this expression? Here we will do the answer in similar way above we have done. D by dx, here will be the capital F of a minus capital F of x by using the definite integrals definition. D by dx, and the remaining term is minus of f of x. Then it gives us minus of f of x, as we have seen earlier. Okay, now our problem is differentiation with respect to x of an integral where the both are limits are function of x. Then what will be the answer? In this case we will take, let's say, the integral that is I. If we solve this integral by using the definition of definite integrals, then it is the I is the function of v and u. Here you can see the definition of definite integral. Here the result is the expression of in the form of upper limit and lower limit. So we can say that the I is the function of u and v. Here is the problem, differentiation of I with respect to x. So it will be partial differentiation of I with respect to v into dv by dx plus partial differentiation of I with respect to u into du by dx. So we'll derive this expression. Here del I by del v means del by del v. The I we have taken u of x, v of x in the both limits f of t dt. Then it gives us capital F of v minus capital F of u. Here, as we know that the definition of partial differentiation, here we are differentiating with respect to v and u has taken a constant. So the answer will be del by del v of f of capital F of v, then it is small f of v. And similarly, if we derive del I by del u, then it gives us minus f of u. So we are substituting these values in this expression. So it gives us f of v dv by dx minus f of u du by dx. So we are substituting the value of I, then it gives us u of x, v of x, f of t dt. It equals to f of v dv by dx minus f of u du by dx. So this is an important formula for us. It is an important formula for us. We will use it later. Okay. Now our problem is differentiation with respect to x of an integral where the both of the limits are the constant a and b, and here the function is f of x comma t dt. It is just a rule, so it will be the answer. The differentiation with respect to x, which will change into the partial differentiation del by del x f of x comma t dt. This is an important result. So these two results, as we have seen, okay, let's say this is equation number, we are taking the equation number, here it is 1 and it is 2 and it is 3. So now our problem is on the differentiation with respect to x where the both limits are the function of x and the function is f of x comma t dt. Then it gives us the answer. We are combining both equation 2 and 3, then we can get the result of this expression. It is our final expression. So we can write here f of x comma here v, so the t becomes v dv by dx minus f of x comma where the t is present, then we will write here the u du by dx plus the last additional term in equation 3, that is where u and v both are the limits, and this is not the function of x, and here the partial differentiation take place, and partial differentiation with respect to x of function x comma t and dt. This is our final expression, which is known as Leibniz rule. So we will do some numericals on this topic. Okay. Here is our first problem, that is given y equals to integration 0 to root over x sine t square dt. Then we have to find dy by dx. That means dy by dx equals to, we can write dy dx integration 0 to root over x sine t square dt. Okay, so here we will use the formula of equation 2. So the formula is given, that is d by dx, u is the function and v is the function of x. So f of t dt equals to f of v dv by dx minus f of u du by dx plus, okay, this is our required formula. So if we use it, so it gives us f of v means sine root over x its square into root x, the differentiation of root x with respect to x, it gives us the half and by root x, and minus f of u means here u is 0, so and this is not make sense. So this is our required answer. Okay, now we will do the second problem. Our second problem is equals to u to v, integration of u to v 1 minus e to the power t by dt, t by t, e to the power t by t into dt. So find del s by del v. Del s by del v, we have done it earlier. Del I by del v, it gives us f of v, and del I by del u, it gives us minus of f of u, and where the I is taken u of x and u of x, f of t dt. Okay, so here the answer of del s by del v, so it gives us f of v means 1 minus e to the power v by v, and del s by del u, it gives us the answer minus of 1 minus e to the power u by u. So it can be written e to the power u minus 1 by u. So in the question, here is another part that is also there, limits as u and v tend to 0. U and v both are the tend to 0. That means if we introduce the limit v tends to 0, then del s by del v, so it gives us limit v tends to 0 1 minus it will be by v, and here if we take the minus, then minus taken as common, so it will be minus 1 by v. It is the formula of limit, that is limit x tends to 0, it will be x minus 1 by x, that is 1, so it will be minus 1. And here if we take limit u tends to 0, then del s by del u, it gives us limit u tends to 0 e to the power u minus 1 by u, then it is 1. So these are the answer. So we will do the in our next problem. The problem is given z equals to sin x to cos x, integration of sin x to cos x sin t by t dt, find dz by x dx. So it is our problem. Dz by dx equals to d by dx differentiation with respect to x of the given integral, where sin x is the lower limit and cos x is the upper limit, sin t by t dt. So as we know that the formula will be where u x and vx both are the function of x and f of t dt. The formula is f of v dv by dx minus f of u du by dx. So if we use this formula, then f of v means sin cos in the replace of t cos x, and by cos x dv by dx means cos x differentiation, it is minus sin x minus f of u means sin in the replacement of t we will write sin x by sin x. The differentiation of du by dx, it gives us the cos x. Then the answer will be minus sin of cos x into tan x minus sin of sin x cos x and cos x by sin x, we know that it is cot x. So this is our required answer. Okay, let's move to our next problem. That is, here is the problem given. The problem is use L'Hospital rule to evaluate limit x tends to 2 1 by x minus 2 integration 2 to x sin t by t dt. As we know that the L'Hospital's rule, if a function f of x is given as g of x by h of x, here is the limit x tends to a. If we apply the L'Hospital rule, then we have to take the first derivative of g of x and the first derivative of h of x. Okay, so here limit x tends to 1 by x minus 2, and here we are taking the first derivative of first differentiation with respect to x of the integral, that is 2 to x sin t by t dt by d by dx x minus 2. And at first we will derive both terms, then substitute it here. D by dx 2 to x sin t by t dt. So we will use the above result. Here is a constant is present, and here the function of here x is present in the upper limit. So the answer will be d by dx a x f of t dt. The formula was f of x. Okay, so here the answer will be sin x by x. Okay, limit x tends to 2 sine x by x, and the differentiation of x minus 2, it is 1. So limit x tends to 2 sine x by x, it will give the answer sine 2 by 2. So now we will move into our next problem, that is 0 to x e to the power minus a square. Here it is ds equals to you. Find dx by du. Here we have to find dx by du. So at first we will derive du by dx. Then here it is d by dx, 0 to x, integration of 0 to x e to the power minus a square ds. So here we will use the formula. The formula is a to x f of t dt. It gives us f of x only. So here the formula is used, then it gives us e to the power minus x square. Okay, and our required answer, where they want dx by du, it will be 1 by e to the power minus x square, and it is e to the power x square. This is our answer. So thank you so much.